Okay, in this video I'll be going through a few of those harder mathematical questions that I've put up for study for the HSC. So the first one here is question 4 in the hardest sheet. So a machine piece is called a cam, is in the form of a truncated cone as illustrated in the diagram. So the part that actually makes up the area of this, or the volume of this, is this sort of section down here. That's our actual object there. And it's made out of a truncated cone, which means basically a cone that's had its top cut off. So the first thing we're asked to do is to use similar triangles to find the dimension labelled x. Similar triangles means the sides are going to be in the same proportion, or the two triangles are going to be in the same proportion. So if I imagine these, we would have two triangles. If you can sort of take the middle of the those middle triangles of the cone there, and this one's going to be 9 across, this one's going to be 6, and the tall one is going to be 21 high, because we're given that just there is given the height of the cone. So what we basically have is that situation of a scale factor. So a scale factor is just the copy over the original, or the original over a copy. It doesn't really matter which way you do that as long as you stay consistent. So in this case, if we look at the two sides we know stuff about, in the copy it's 6 high, 6 is the bottom of that triangle, and in the original it's 9. So we end up with a scale factor of 2/3. And then what we need to do then to find our equivalent side, to find out what this side is here, based on the fact that that one's 21, we use the same scale factor. So we have 21 times by 2/3 should give us that size of that area there, height there. So that's going to be 14 centimetres. So 21 times 2/3, you can use your calculator, or you can divide 21 by 3 and times it by 2, whichever way you want to do that. Okay, so moving on to B, we need to find the volume. So to find the volume, if you have a look on your formula sheet, you've got a formula there that says volume equals area, 1/3 of area times height. And that's the formula for the volume of pyramids, and a cone is kind of a circular pyramid, for want of a better word. So we just need to know the area of the base. So in this particular case, we're going to actually use volume equals 1/3. Now the area of a triangle is, area of a circle is pi r squared, and we still use the h. So we've just taken that little bit in the middle, that area, and we've replaced it with what the area of a circle usually is, but it's still the same formula. So in order to do this, we take we'll work out what our big cone is, and we'll work out what our small is, and we'll take the volume of one away from the other. Because essentially what we've got here is we've got a big cone, and if we take away from this small cone here, we'll be left with the part that we actually need, the part in yellow down the bottom. Okay, so using those formulas, we're going to have the volume equals 1/3 of times pi times the radius. The big one is 9, so 9 squared, and the height of that one is 21. And for the small one, I'll just leave a little divider there. The small one is going to be the volume equals 1/3 times pi times 6 squared times 14, which we just worked out. Now, using your calculator, you're going to get yourself an answer. Make sure you check this. You should get something in the order of 1781.28 centimetres cubed, and the other one is going to give us something like 527.79 centimetres cubed. So obviously, to work out the total area, we're going to have to go the total equals the big minus the small. So that's going to be 0.28. Take away 527.79, or thereabouts. Obviously, try and keep those numbers in your calculator if you can. But you're going to get something in the order of 1253.49 centimetres cubed. And that gets us to the end of part B. Then finally for part C, we're being told that the mass of steel is 7,850 kilograms per metre cubed. Now we've got our dimensions here in centimetres cubed, so we're going to need to change that into metres cubed so we can find things out. So obviously when we convert from centimetres to metres, there's 100 centimetres in a metre, but when we convert from cubic centimetres to cubic metres, we've got to convert 3 times, once for each dimension. So there's 3 dimensions, we've got to do that conversion 3 times. So to work out what 1,253.49 centimetres cubed is in metres cubed, we'd need to take that 1,253.49 and we'd need to divide it by the 100 centimetres in a metre for one dimension, the 100 centimetres in a metre for the second dimension, and the 100 centimetres in the metre for the third dimension. So effectively going to divide it by 1,000,000. Okay, so that's going to end us up with 0.012, isn't it? Oh no, 0012, 00125349 metres cubed. Okay, so now we have our answer in metres cubed. We can use this value we've been given here. So we know that for every metre cubed, we've got 7,850 kilograms of steel. So therefore we can say that the mass is just going to equal that 0.00125349 times by the 7,850 kilograms that would take up. And we put that into our calculator, we're going to end up with something in the order of about 9.83. Now your decimals might be out a bit the further we go along, depending on where you simplified compared to me. So there we go. So I get that in kilograms, but of course read the question, and this question wants it in the nearest gram. So we just have to convert that into kilograms. From kilograms to grams. Obviously in this case we just have to multiply by 1,000, so it's 9,840 grams because it's said to the nearest gram. So if we round up, 9,839.8 grams would round up to 9,840 grams. And that's everything for that one. A fair bit to do there, a little bit you need to know, but achievable. Or I guess at least in the sense of you should be able to jag some marks out of him. Okay, so moving along to the next example, which I was going to do example 9. Now this one's a little bit curly. Basically, there's a couple of really strange things in here. The words "the same interest" mess this one up a little bit. So principal of $1,000 invested for 3 years at an interest rate of 5.6% compounded half yearly. Determine how much needs to be invested to achieve the same interest. Not the same balance, the same interest, if the interest rate was 3.5% compounded monthly. So the very first thing I think we do is we draw a line here and we just say, well, look, everything before that we need to look at first. How much interest do we get on $1,000 invested for 3 years at an interest rate of 5.6% per annum? So to work that out, we just use our usual future value formula. The future value equals the present value outside of 1 plus r to the n. And in this case, my r is going to be 0.056 over 2 because it's half yearly. And my n, I'll just make that look a little bit more r-ish. There we go. And my n is going to be 3 years half yearly, so there's going to be 6 periods. So if I just substitute in my formula, the present value is $1,000, 1 plus the rate 0.056 over 2 to the power of 6. I put that all through my calculator and I should get something in the order of, where do I have that here, $1,180.21. Now the important thing to remember is that's the future value, but the interest is the future value minus the present value. So that's going to be 1180.21 minus $1,000. So that's going to leave us with $180.21. So what we're trying to now do is we're trying to invest at a different interest rate for a different with different compounding periods, but get the same amount of interest. So we've kind of got to look at that formula again, and if we look at our future value formula, future value equals present value 1 plus r to the n, well, we can really just think of this future value here as being, well, that's just the present value plus the interest. So actually what I've got is the present value plus the interest, which we worked out is 180.21, should equal the present value, whatever that is, times by 1 plus, well, what's our rate for this one? So 3.5%, so 0.035. But how often am I compounding? I'm compounding monthly, so I have to divide that by 12. And we're still going to invest it for the same amount of time. So we're still going to invest for 3 years, but 3 years monthly compounding. So 3 times by 12 is going to give us 36 months that we're doing that for. Now, the next step I did here was to actually work out what all of this stuff on the right-hand side is here with this 1 plus 0.035 over 12 to the power of 36. I thought, well, let's just work that out. So let's put that into our calculator. 1 plus, open a fraction, 0.035 over 12, close the brackets, and we go to the power of 36. And we find that that's 1.110 something. So I'm actually going to end up with the present value plus 180.21 equals 1.11 ... lots of the present value on this side. So I need to get it in terms of present value equals. So if I take away the present value from both sides, I'm going to end up with $120.21 equals 1.11 whatever lots of the present value take away the present value. So 1.1 lots of the present value take away 1 lot of the present value is just going to leave me with 0.1. So in the same way, so 180.21 is going to get me 0.11 ... lots of the present value. Now I still have that number in my calculator. Actually, what I'll do in my calculator here is I'll take away the 1, and so that's what that number is in my calculator. So the next thing I need to do is divide both sides, because there's multiplication going here on the right hand side. I can go 180.21 divided by 0.11, whatever that is, equals the present value. So I just sum that into my calculator. In this case, actually what I'm going to do is I'm going to go 180.21 over the answer we previously got, and I get $1,630.26. So that's how much I need to invest to earn the same amount of interest. That's pretty full on and involved there, so that's a pretty difficult question. So I'm just going to pause the video here. I'll actually set up a little bit different so I can do question 10, because that's the next one I've been asked about. And we'll come back there.